All right, so just a little bit about myself. Like Glenn mentioned, I work at Headspring, where usually I'm helping our teams build systems. And so this talk is actually a story of one of the systems I was working on, where I saw something that looked not so good. And this is the story of us trying to figure out how we can fix it in the different possible ways we could get there. You can find me on Twitter at @jbogard. You can also find this presentation and anything I do on my GitHub at github.com/jbogard. And I also blog on jimmybogard.com. I used to blog on a site called Los Techies. That's our mascot, Pablo. So all my old posts are still there. That site's still chugging along on WordPress 1.0 or something. I don't even know. I get this for, I don't know why. They don't tell me why I get this thing, but it gets me free stuff. So yay. And I do a lot of open source work based on all the projects I do at Headspring. So yeah, back to our topic here, fixing distributed systems fail. So this actually started a little over a year ago, where one of my coworkers, Bill, came up to me with this really worried look on his face. Like, it was right before the Christmas break, and he saw some code, these 6 little lines of code that really, really worried him, and he was trying to figure out how best to fix them and how to go forward. So this site was the code in particular was part of a website where you check out and buy some products. So it's basically, you click the button, and then it does all the things, and hopefully at the end of it, they take your money, and then you get whatever you're supposed to get out of it. But he saw what he thought was some problems with it, so I said, okay, let's get a conference room. I'm sure it's not that bad. I'm sure it's just fine. You're just worried because it's almost Christmas time. You want to go home, whatever. But I look at it, and I'm like, uh-oh, this actually is bad, and we need to figure out how to fix it. So the rest of this is a story of us seeing what the code did and then trying to figure out how we could fix that code. And so the code looks something like this. Didn't look exactly like this, of course. I've changed it a little bit to try to protect the innocent and not point out specific customers we were working with. But it looks something like this. This was part of an MVC application. So this is the code that ran when you click the button. This is the code that actually ran on the server side. Now these days, it's really easy for us to use all sorts of external APIs and systems and use that as part of our code base. So this code base was using just Entity Framework, a regular database behind the scenes, but it was also using Stripe API to actually process payments. It was using SendGrid to send emails, and it was using RabbitMQ for messaging to notify some downstream systems to actually do some shipping of the order and things like that. And so it did all of this as part of the button click. So the first thing it did was find the customer information from the database. It would create the order from the cart and the customer details that it found from that customer plus the cart information. The next thing it did was post the payment to Stripe based on the cart information. So far, so good. It would send that thank you email via SendGrid. So if your payment succeeded, you'd get an email saying, thank you for your purchase. You will have it shipped to you shortly, something like that. It would publish a message out using RabbitMQ, and then finally it would redirect the customer to a thank you page. And outside all of this was the DB context save changes. So Entity Framework, to actually commit the changes to the database, would call it somewhere, I think it was in a action filter, so somewhere like around here somewhere was actually saving the changes to the database. So the reason why he was so worried is because the code that was written assumed that everything would always succeed, that nothing would ever break. And for most of the systems I run with, especially web applications, it's okay for us to not worry about something going wrong because everything's in a database transaction. If something fails, the database transaction rolls back, and everything's as it was before. Now, it's not that great for the end user because the end user sees that horrible screen of stack trace, or maybe there's a better error screen, but the end user still sees that something went wrong when you redo your order. But if I see that on one of these pages where I'm putting my credit card information in, and I see an error coming up, I'm like, that is something you never, ever want to have happen. So when dealing with systems I can't control, instead of just assuming things always succeed, I have to take a different thought in my head, which is to always assume that something is going to go wrong. Especially looking at all those different pieces that are going on there, something could possibly go wrong. So we sat down with a code base and said, let's go one by one and say what happens, not if something goes wrong, because when you say if to the business, they get this happy thought in their head, like if something goes wrong, well, nothing ever is going to go wrong, so let's just assume everything's okay. I use when, so when something goes wrong, what is the side effect there? So this is the basic flow that we drew it on a whiteboard. We said that as part of making this call, we have a transaction that happens. We make first a call to the database to go get the customer information. Then we make a call to Stripe, a call to SendGrid, a call to RabbitMQ, and then finally at the very end, we commit the transaction. So we took each of these calls one by one and said, what happens when this call fails? And how is the end user, the end customer, affected by that failure? So first call to the database. What happens when that fails? Well, for them, the transaction will still roll back, so they won't have the order in the database. An error is shown to the user, but otherwise the system is okay. Like we show something bad to the end user that they don't want to see, but otherwise the rest of the stuff should be okay. And this is kind of normal operating the systems I work with. The database transaction just rolls back and we're okay. Okay, so what about when Stripe fails? What happens when Stripe goes down? It doesn't matter why Stripe goes down, by the way. It could be that the API is actually down. It could be that the API is slow, so we made a call to Stripe, but it never returned a result, so we just assumed that it failed. It could be that we mistyped the API key in our config file, and so something failed while calling Stripe. It doesn't really matter whether something happened calling Stripe. So okay, so in this picture, what happens when Stripe fails? Well, that means that this call succeeded to the database, so I created the order. However, because we wrapped that in the transaction, we're still okay. So no money gets posted to their accounts. The transaction rolls back, so everything is still okay. Now, next is when things start to go horribly, horribly wrong. So what happens when SendGrid fails? Which does happen. Even Google goes down sometimes, right? I sometimes log into my Gmail. This is like, what, once every 2 years? And it comes up like nothing comes up. Of course, the internet and Twitter blows up. It was like, oh my God, Google's down. This is never. So if Google can't be up all the time, then what hope does anyone have, really? So yeah, what happens here when SendGrid goes down? Bad things. Because this initial call succeeded to insert rows into the database. The call to Stripe succeeded. However, once we get this blow up here, we get an exception. And so our normal exception handling logic says, when you get an exception, don't commit the transaction. So that means that the customer was actually charged, but the transaction rolls back, and so I have no record of the order in the database. Now, of course, the customer has a record because they look at their credit card statement and say, wait a second, you charged me for this thing, then you call customer service, like, you charged my card. And then the customer service rep goes look in the database like, I'm sorry, sir, we don't have an order in the database. And so what happens then? We get called, right? We get called to say, of course they're mad as hell, right? They're like the customer service rep is angry, the customer's angry, and the only thing we have to go from is hopefully we have logs. Right? We do have logs. We're logging stuff, right? Yes? Yes? Yes, maybe, kind of. That's the thing that no one ever reads ever until something blows up and you hope that you logged enough information. But of course, you're not logging like everything. You're not logging every single call to the database because that has sensitive information, as credit card information. You don't want to just stick that in a text file. So maybe you can go back and see, but what typically would happen was just we'd give them a refund and they would never come back ever again. Lost customer. Okay, so what about RabbitMQ? What happens when that goes down? Now, this is one of those things like your database. I typically assume that my messaging systems won't go down. That's kind of like internet going down or the phone network going down. You just generally assume if those go down, nothing happens. You just go home. Like just take the day off, nothing can happen. So I kind of assume that the database and this will be up, but it can still be possible that something happens in this communication to RabbitMQ for whatever reason. For example, we had one of our internet service providers decide to upgrade the software on their switches without telling us. And so we lost all connectivity to all of the things we talked to because they didn't put the same firewall rules back in when they upgraded the switch. So even though this was technically up, we couldn't talk to it, and so it could still blow up. So what happens here? Well, the initial call to the database succeeded, so we inserted rows. We made the call to Stripe, so we charged their card. We told them about it. We sent them an email saying, thank you for your order. Maybe even had a link to say, click here to view your order. But because of this exception, the transaction rolls back and there's no record of their order in the database. So we've actually sent them an email. Not only do we charge their card, they can go click a link. They click the link to view the order, 404. Order not found. Again, not the best thing you want to show your customers. And again, that's probably just a complete lost customer at that point because they're screaming at the customer service rep, they're screaming at you, and they're never going to come back again. So again, bad. Okay, the very last one. This is probably the worst one, but it still can happen, which is what happens when the transaction fails. So this means that I made the call to the database to insert rows. I made the call to Stripe to charge the card. I made a call to SendGrid to notify the customer. And I've also notified downstream systems to go ahead and ship the product to the customer or whatever the downstream systems do. So a very bad spot we're in because not only have we notified the customer, we've actually notified downstream systems. The downstream systems go back and say, okay, I'm ready to ship this order. Let's go to the order database. No order. So, and this can absolutely happen. We can have some kind of deadlock in the database that can make this fail, and so the transaction rolls back, but we can't retry anything. The web, they click the button and that's that. We only get that one chance to do it. So this is definitely something that can happen, but all these downstream systems don't know about this failure that's occurred. So this was the picture that we drew on the whiteboard of all these things that can possibly go wrong. And the next question is, okay, what do we do? Do we go to the pub and just drink our problems away and like hopefully things get okay in the end? And looking at the code though, like probably nothing was a wrong answer. Like probably shouldn't just be like, shrug our shoulders, like, if something goes wrong, screw the customer, whatever, who cares? So the customers are directly affected by each one of those failures, and if you've ever been on a website that fails at checkout, you don't go back because you've lost all confidence in their ability to take like the fundamental thing they do, take your money and give you something in return. If they can't do that, then what? Like there's no hope. So just like is probably not a good choice here, but that was the choice the original developers made, which I tried to find out. Glenn asked me, who made that original code? I'm like, someone moved the file in a directory somewhere and it's lost all history, but I guess if I dug far enough, I could probably find out. You know what probably is? It's actually probably me. If I dig far enough, it's like, I committed that 4 years ago, and it's inevitable. So we can't just throw up our shoulders and just say, not going to happen. Let's just assume everything succeeds. That's not going to be good for business. So what we can't do either is just say, well, let's just make everything either succeed or fail. So if something goes wrong, just roll back the entire transaction. So extend our box from the database all the way over to all these services and put everything inside a transaction. Has anyone ever tried to do this with the old web service stuff? What are you pointing at me for? Oh yeah, I have tried to do it, yes. So like 10 years ago, the Web Service Standard Committees tried to expose protocols so that web services could be in part of transactions. But of course, no one agreed about what those standards could be or how they should actually work. Have anyone ever tried to consume a web service from a Java service? Yes, it never works exactly as advertised. You usually have to go in and hand fix some stuff. And so the companies behind these different APIs don't even want to do this in the first place. Stripe doesn't want you to open a transaction with them because they have this like weird transaction protocol that have to adhere to every single one. No, they don't want to do that. So the answer can't be just wrap everything in a giant transaction so that it all succeeds or fails. We need to assume that things are going to fail at every step along the way and plan for the worst. When we plan for the worst, we have to decide, okay, assuming each line of code could fail, how then do we deal with each of those failures? What should we do? Luckily, we don't have to come up with all this ourselves, make it all up ourselves. When we looked at this, I could go back to established books, papers, blog posts to say, when you have these different APIs and distributed systems you're dealing with, there are established ways you can actually deal with those failures. And the paper I like the best is one from this guy, Gregor Hope. I don't actually know how to pronounce his name. It's a paper called Your Coffee Shop Doesn't Do Two-Phase Commit. And the basic idea is that the real world out there, when you're like actually conducting business with other people, no one actually uses this concept of transactions between different things. It just doesn't, that concept doesn't exist in real businesses because that kind of transaction is extremely expensive to do. And so in this paper, it actually used to be called or Starbucks doesn't use two-phase commit, but something happened, and now it just says your coffee shop. I can only assume that Starbucks was like, nope, squash, don't do that. So now it's your coffee shop doesn't use two-phase commit, and in it, he talks about when you go to a coffee shop, those different people behind the counter aren't doing any kind of transactions when they're working back there. Everything is much looser in order to be able to actually deal with the realities of doing business. So he lines up 4 possible options when dealing with failures between more than one system, 2 systems, 3 systems, 4 systems, and the different ways you can deal with them. So the first way of dealing with a failure between 2 different resources, so I'm doing with something with resource A and something with resource B, the first option would just be to ignore it. To say, something failed with the second resource, just ignore it and move on with our lives. Now, you may think that that's not a valid option to just ignore failures, but in some business use cases, it may be an option. Things like, what happens if the printer fails on the receipt printer? Are you going to not conduct business? Or are you just like, sorry, you don't get a receipt? Ignore it and move on with your lives. So that could be a possible option for some of the things we're working with. Option 2 is to retry that operation. So I do something with A, do something with B, B fails, and something just tries that thing again against this resource B. Now this can be tricky because we need to make sure that the thing we're doing is actually a thing we can retry, that if we do it once and it fails and we try it again, that it doesn't accidentally happen twice. So if I'm dealing with things like money, for example, I want to make sure that this doesn't double charge someone accidentally. So I have to be very, very careful to make sure that this is actually something that can be retried. Option 3 is to undo. The idea here is that instead of me retrying this operation over here, if something fails, then I go back to the first resource and say, undo whatever you did. Now this is different than a transaction. So a transaction would just, the changes would never go on in the first place. So this is assuming the changes actually went through. Whatever that operation did actually went through to the other resource. And so I need to have some kind of undo action to undo whatever the thing is I did before. So that means that whatever I'm dealing with has to have the ability to undo an action. And if they don't have that ability, then I can't do this. Now the final one is the most expensive one, and it is to do a coordinated transaction between these 2 resources. So this is the two-phase commit protocol, in which I have the first step that goes to the first resource and says, are you good? I go to the second resources and say, are you good? Once they get the thumbs up from both of those resources, I say, okay, the first person needs to commit, and now the second person needs to commit. And then everything's good. And hopefully something doesn't fail between me saying, okay, commit, if I die or something, then that's not good. Now you may have actually dealt with this in the real world at some point. So if anyone here has had to buy a house, and you've had that is it a realtor or mortgage agent? Yeah, title company, something like that. So there's this third party that deals with both the buyer and the seller. They go to the buyer and make sure that they're okay with that price and make sure they have the deposit to be able to purchase the house. They go to the seller and say, are you okay to buy this for this amount? Then they get the signatures from the buyer, the signatures from the seller, the big check changes hands, and then the house is purchased. And so that title company or mortgage agent, whoever it is, that third party acts as this coordinator between two resources so that it all succeeds or it all fails. But that's expensive, as I found out when I bought a house and I had to give that % money to the person just sitting here watching me sign pieces of paper. This is an expensive operation, both in real life as well as in the systems we build. You can just see the number of arrows we've added adds to the expense of doing this activity. So, given those 4 options, the master plan was to look at each one of those external calls we made and evaluate each of those options and to say, okay, does that resource even support this way of dealing with failures? 1. And 2, what does it actually mean to do that to the end user, to the customer? So if I did an undo, how would that actually affect the customer? This is really important for us. We always need to make sure that both the business was informed of the different options and that whatever we did, it was very obvious to the end user what was going on. So if something failed, we didn't just pretend like it succeeded and then they wondered why their bank account had the money taken out or didn't have it. So we wanted to make it very obvious to the end user as well. So first up was Stripe. So just a reminder, this is what the code looked like before. Call the database, insert in the database, call Stripe, call SendGrid, ooh, let's not touch it, call RabbitMQ, and then finally redirect to the end user. So option 1 is to ignore. Probably don't want to ignore a failed payment because we want their money. We don't want to just oh, Stripe's down? Well, you can have it anyway. Sorry. Just give it to them for free. But I have seen this in the real world. So we have food trucks that we have in our office. And sometimes their credit card machine is down. And they have to make a choice. Do I just not give your food to you because you wanted it? Or do I accept cash? What do they do? So some places will accept cash at that point. Other places just close down and say we can't do anything. But it's a business decision exactly how they want to deal with those failures. So in this case, we probably don't want to just ignore a failed payment altogether. That's probably not a good option. Okay, option 2 is retry. Now this is tricky again because we don't necessarily know that just because we get an exception from an API call that it actually failed on the server. Because we could have been making a call to Stripe, it's doing its work, but on our side, we actually just have a timeout. We're just waiting to get a response for 15 seconds, 30 seconds. And if we don't hear anything, by the time that timeout is done, we assume it failed. But that doesn't actually mean it really failed. We have one of our clients that instructed us that we needed to up our timeouts on a web service from the normal 15 seconds default to 2 minutes because that's how long the web service could take. It's really the user's just sitting there waiting, looking at, I hope we have a really good spinner GIF because that's a long time to wait. Okay, so you can't, just because something we would get some failure message back doesn't necessarily mean that the actual work truly failed on the other side. So we need to make sure that if I retry the call to Stripe, I don't double charge the customer. That's like worse than, even worse than like showing them an error page is charging them twice. That's getting them twice as mad, or probably 4 times as mad. There's some kind of like curve that goes up for how much you extra charge them. So there's a thing you have to look for when dealing with making a call twice, but only doing the thing once. There's a computer science term known as idempotency, which just means if I make the call twice, the effect of my call only happens once. So I can call it multiple times, as many times as you want, but whatever the work was being done behind the scenes, it only happens once. You can think of this in terms of like someone telling you to turn on the light. If the light's already on, you're like, done. So however many times they tell you to turn on the light only gets turned on once. Now that's a kind of a natural, action that is idempotent, but not everything is like that. And so what Stripe has, and this is literally what I do, is I just Google service, whatever the service is, idempotent, and see what pops up. And luckily, Stripe's documentation, which is awesome, popped up idempotent requests. And in here it says, this API supports idempotency for safely retrying requests without accidentally performing the same operation twice. That's exactly what we want. And the way we do this, it is cut off. It says to perform an idempotent request, they don't do this by default. If you call them twice with the same amount, because you could think of like, well, how would you know if something was a double charge? Is it the same amount by the same person at roughly the same time? Would that be a double charge? I mean, I've seen that sometimes. Like if I checked an untapped twice with the same beer in 15 seconds, it tells me this looks like a double check-in. I'm like, no, I'm pounding it back 15 seconds later. So you could look at it like, well, it looks like it's a double. So they just said, no, we're not going to guess if this is a double charge. You tell us by passing in some sort of unique identifier with that call so that every time you make that charge, you pass in that same ID. So this means it puts the burden on the client to invent some kind of unique key. And so we looked at it and said, what is the thing that is unique that identifies us clicking the button? And it turned out it was the cart ID. The cart ID represented that unique request to buy something, because once we bought something, we cleared the cart, deleted it, and it was gone. So when I click place order, it's supposed to convert the cart into an order and take your money. So that cart ID was the natural thing for us to look at to use for posting the payment. So this is now retryable. However, I haven't shown the code that actually does like what's retrying this? The browser? Something outside of this that's just in a for loop for forever? Maybe Stripe comes out. So we still have to think about how would we actually do the retry. But at least we know if this is like if someone double clicked or something stupid like that, because my mom, she double clicks everything, at least it would be able to handle that. Okay, so option 3, undo. So retry is easy to Google for, undo is hard. Because undo, you have to think about what is the natural undo for that operation, whatever that thing is. So what does it mean to undo a Stripe payment? Refund, yes. So you imagine yourself in a store, you're buying some clothes. You give them the money, they give you the shirt, you see there's a hole in it, you don't reach across the counter and grab it, right? You don't just like yank it back from them. Instead, there's another transaction that happens that you say, okay, I want a refund. You give them the shirt, they give you the money, and then you're done. Just don't forget your receipt. So we have to think creatively when we're looking for undo with respect to whatever we're dealing with here. And so I look for Stripe, like Stripe refund. And, ta-da, documentation. Yay, Stripe. Great documentation that just says, for a refund, you just give them a transaction ID, and they will refund whatever the amount was. Done. So for us, that means we can do something like this. We do our normal, like, take the customer, insert the stuff, call Stripe, but now we capture the payment information here, call SendGrid, call bust.publish. But if something goes wrong here, then in the catch block, if we actually posted the payment, then I'll say Stripe refund. Now this isn't completely correct because we had the transaction that was happening, so we had to take care of that. So we actually want to make this even more complicated, which was make sure the transaction commits actually is part of all these steps. It used to be in a action filter, somewhere like over here somewhere. And so we said, no, make it explicit. Explicitly commit the database transaction here so that if something goes wrong here, we catch it and we can refund their money and then roll back the transaction if something went wrong there. And then finally, we actually still show the user an error page. I mean, at some point, you have to let them know something went wrong. Now you may be wondering, like we said, always assume failures, but we're still assuming that this succeeds. Next option. We're just going to skip that because eventually, you can't. You have to get to the point where you just okay. We have to do something else here. So option 4, coordinate. I already said Stripe doesn't do transactions. Like you can't enlist into distributed transaction with Stripe. They don't expose any kind of transaction web service protocol, nothing like that. So they have to get a little creative here when I was Googling of what does it mean for this for this sort of two-step, first say do they have the money and then actually take the money. And it turns out they have this concept of a two-step payment flow. And you may notice this in your bank statement. Have you ever noticed when you log in your bank, it says pending transactions? That's what this is. They've actually authorized, but they haven't actually taken the money out just yet. And there's a reason why the banks do this. It's to screw you, it turns out, because they process all the taking the money out first and then putting the money in, so that if you take money out and you don't have enough money, then they charge you. So it's just another way the banks screw you over, I think. And so that's what you can do here with Stripe. That you can do a two-step process where you first authorize the card to say, do they have the money? Okay, and then when you're done trying to do something, then you say, go ahead and capture that amount then from their account. Some e-commerce systems do this. They'll do this on the front end to say, authorize the card, and then when they ship the product, they actually charge you for it. So if it's something that needs to be reserved for that amount of time, they'll use that authorization to sort of hold it to the side, saying, you know, you're trying to get this thing, and I'm going to put it to the side, and then when you finally capture the money, then we'll go ahead and give you the product, whatever that is. So it looks something like this. The code's getting more complicated, I know, where we would initially post an authorization to Stripe, and then if everything succeeds, then down here we'll actually capture the money from them. Now, this does look weird in their bank account. So if something goes wrong, when something goes wrong, so let's assume that this call fails. What does that mean? Well, it turns out everything else succeeded, so we notify them. And we've kind of put our finger on their money, but we haven't actually gotten it yet. So what would happen here is the administrator would have to look at these logs to say something went wrong, and then they can go log into the Stripe user interface and then actually manually capture the money from the UI. So the user thinks it succeeds. It kind of failed, but we can still get the money and everything should still be okay. So this is not a bad solution, but it does introduce this concept of a two-step post and capture, which would look weird in their bank account because they'd have this like temporary authorization, and sometimes that I would just get questions about that. So that's a question for the business. So that's Stripe. What about SendGrid? SendGrid is a totally different kind of service than Stripe. Stripe is all about making sure that that transaction that you're taking money is that doesn't fail and you have all this traceability around it. SendGrid is the exact opposite. They're all about speed. If you call their API, they're going to send that email as fast as possible. Where Stripe is like, well, you can kind of undo it. You can go into the UI and like refund money. SendGrid is the exact opposite. They're like speed, speed, speed. So 4 options again. Option 1, ignore. Again, just a simple try-catch. Try to send the email to SendGrid, and if something failed, we just log an exception saying, oops, couldn't send the email. Is this okay? Maybe. I don't know. I'd again have to talk to our business to say, hey, is it okay that if SendGrid goes down, we just don't send emails out? Is that okay? I mean, maybe. I don't know. It depends on what we're selling and how important that email is. If it's just a thank you for your order, then maybe it's not that important. So we have to ask them, is it okay if we just completely swallow the errors and then maybe they manually send you? I don't know. But it's definitely a question for the business here. Option 2. I should say that one thing about this is I always ask the business, is it okay that when SendGrid is down, we can't take anyone's money? Is that okay? Because before, when SendGrid went down, we couldn't do anything. Like we enter the database, call Stripe, but even if we fix Stripe, do I really want to tie my ability to just sell products to whether or not I can send emails? I don't know. Probably not. All right, option 2, retry. So you Google SendGrid idempotency. All you get are Stack Overflow questions with no answers. That's never a good place to be in. And so why is this? Well, if you think about it, how does Stripe handle that situation? They have a record of all the transactions. And so when you call into them to say, I want to make this, they have to go look up to say, oh, have I done this before? That's slow. It's slow to go back and look up in my transactions to say, should I do this or not? So SendGrid wants to go fast. And it would be slow for them to keep all of the calls to your emails about whether you want to send that email or not. So for them, the answer is, yeah, you can call us twice, and you'll get 2 emails. So don't call us twice unless you want to have duplicate emails. If that's okay with you, call us as many times as you like. If you don't want duplicate emails, don't call us multiple times. So again, a question for the business. Do you want 0 emails with the ignore? Or do you want potentially multiple emails with the retry? What do you want? They would say neither, but that's not a good answer. So we'll get back to this. Undo. Cannot unsend emails. As much as I've wanted to, like I hit the send, I'm like, oh no, I misspelled something, or I had too many drinks or something. You can't unsend emails. So this one is like, if I accidentally send an email to someone, what do? Apologize? Like, sorry, we sent the thing. But at this point, it's a business decision. How do I recover from accidentally sending an email? But this actually happened to me. One of my, Glenn, I don't know if you were there for that. I think you were. My biggest failure at Headspring when I sent accidentally issued coupons to like 100,000 people and emailed about it, and we couldn't just like un-email them and say, oops, sorry, you can't have that $10 coupon. That was horrible. Horrible. Okay, so yeah, actually for that, we actually did apologize. Like, oops, sorry, we received that in error. And so we gave them like vouchers, or I forget exactly what we did. Okay, so the last option is to coordinate, which I don't even know what that means. Like, what does it mean to have a coordinated send of an email where I send the email, but I put my finger on it and I'm like, okay, now it's good to send. The only client I've seen do that is Outlook. When you're disconnected, you can send emails in Outlook and they just sit on your hard drive. And when you get the internet back again, then they go ahead and send on through, but only if you're using the desktop app. So technically, you can like undo the email by deleting those emails, but if anyone's ever actually done that or not. But so this doesn't even make any sense. We can't have like a coordinated, like, prepare to send email, confirm to send email. Like, that just doesn't make any sense. Okay, finally, RabbitMQ. Now, RabbitMQ is going to be very, very similar to email because it's messaging, and email is very, very similar to RabbitMQ's messaging. They're really built on top of each other's concepts. So our options are going to be very, very similar here. Option 1 would be to ignore. Now, with the email, when we ignored it, we just didn't do anything. We just said, completely try, catch, who cares? With this one, we don't want to just completely ignore that failure. Maybe we have a recovery process. So in this case, instead of just me completely ignoring the failure, what I can do is set a flag on the order to say, hey, this failed to send, but I'm going to set a flag on the order so that some process is just, like, maybe nightly, every night there's a batch job that looks for orders that need that message to be sent, and they'll go ahead and send it out the door. So in this case, I can still have this be down, but I have some sort of recovery process that's able to look for orders that still need that event to be raised, and will recover from it eventually at night. Now, maybe the user gets their order a little bit later, but they still get their order. Option 2, retry. Now, Stripe, we saw, did support retry. SendGrid explicitly did not support retry, but what about RabbitMQ? This is where things get a little funny. So what does it mean to retry Rabbit? That means that the first call could have succeeded, but we're trying it again. It could have succeeded, we just didn't wait long enough. We didn't wait for that second call to say, yep, it's good. The documentation for Rabbit on this sort of thing is way more complicated to read than SendGrid. SendGrid is easy to read for developers. RabbitMQ, I think, is for, like, administrators. It's way more difficult to read. So it took me a long time to even understand what options were available and then how would I actually configure it. So for them, when you retry, you're not just retrying Rabbit, you're potentially retrying all the different consumers that are actually receiving that message downstream. So not only would it have to, like Rabbit doesn't support retry out of the box, I would have to go to all my different consumers and say, hey, by the way, you need to handle getting this message twice. And they're like, screw you, don't send me this message twice. That's a lot of work. So this one's going to be tough to put that burden on everyone downstream. And if there's some new consumer that comes online, do I have to go remember to have a meeting with them to say, hey, don't forget, make sure you can handle this message twice because I can't deal with it on my side. Option 3, undo. Again, you can't unsend an email. You can't unsend a message. And unlike email, where you can have an apology email, this one, there's no, like, what do? Like, order accepted. Next message, actually, never mind. Order not accepted. Oops. Like, it'd be really, really strange to have this kind of thing in there. So like, it's a kind of like, it just doesn't make any sense. And finally, coordinate. RabbitMQ explicitly says we do not support this, and we will never support this. Now, some queuing systems and messaging systems do support this. So if we were using MSMQ, it does support a distributed transaction, with a caveat that you have to open a bunch of ports that your network administrator will strangle you for, because they're just these random list of weird ports that they want to open up. And it's also very, very, very slow. When we measure this, it was about a 10 times drop in throughput of messages when we turn this on. This is why Rabbit is like, nah, we're not going to do this. It's way too slow, and there are better ways of dealing with it, which we will see. So, looking at, I wish it was simple, but the APIs make it so easy to call, but it turns out like the reality is that dealing with failures is difficult. So looking at the options and the different services, they're all opposite. Like Stripe can't, you don't want to ignore, but it can do all the rest. Whereas SendGrid and RabbitMQ are okay to ignore and don't support any of the others. So I can't even have one solution for everything. I have to look at every single one by itself. So this is where I took a step back and said, this code looks ugly. every single example you saw was just fixing one of the problems. If I tried to fix all three all at once, it'd be these like nested try-catches with weird flags and just like, that looks so ugly. How am I ever going to maintain this over time? So we took a step back and said, the real problem here is that I'm trying to do all these different calls inside a database transaction. That's my real problem. What if I didn't do that? What if I didn't do all these API, web service, messaging calls inside of a database transaction and try to break the process apart between the things that could fail and I can't control, and that part, the database, like I should be able to control that piece. By the way, this is known as process coupling, where I'm putting things together in a single process that don't necessarily belong to each other. Now, coupling is one of those things that's neither good nor bad. It's just a decision. It just is. Like sky is blue, there's process coupling. The next decision is, do we actually need to have that process coupling? Now, this is where I have to talk to the business, because they have to decide, are we going to do this thing when they click the button, or are we going to do it sometime later? And that decision has real business implications. So I don't want to decide this as a developer. If I was a business, I wouldn't want to decide it. I would be like, can everything just succeed all the time? That would be great. So we went back to the drawing board again and said, okay, what would it look like if instead of us calling this here, we called it somewhere else? Like, I don't know where, sometime later, somewhere else, just not right here. So Stripe, what would that look like? What would it mean for me not to take your money right away, but to take your money sometime in the future? Now, we actually asked this with the business. And they said, well, for some things, it's okay to take your money later. But for us, we really need to take your money now. The reason being is that this was for a tournament with only a fixed number of spots in the tournament, like a poker tournament. And, well, I guess some poker tournaments have like infinite people. You can have as many as you want. But this one had a very fixed amount of spaces. So they said, you know what, we don't want to accidentally overbook and then have to tell someone, sorry, you're actually not in the tournament, or flip a coin. I don't know how they would decide. So they said, we actually want to try to take their money, but if that fails, we'll just flag the order. So it looks something like this, that they would try to take your money, but if that failed, they would just mark the payment as failed on the order, and then some back-end process would again go look to see what are the orders with failed payments, and then go ahead and try to make the payment go through. The idea is that Stripe doesn't fail that much, and if it fails, it's failing for a long time. So we'll just make good and like call the customer back and say, hey, looks like it didn't go through, and we filled up on that Thursday. Can you do Wednesday instead? So they're having to call the customer to do this. Sometimes that doesn't work. And you may notice this in some websites. You ever have those websites where you see the timer counting down on the checkout page? I'm like never so nervous in my life when I see the thing like 10, 9, I'm like, where's my credit card? It was like 8, 7, I'm like, So in those cases, they have to take your money when you click the button. So they have this countdown timer instead. For us, we'll try to take the money, and if something goes wrong, we'll just mark the payment as failed. Or we may not even take their money now at all. Do we even have to take their money? Can we take their money sometime in the future when we actually ship the product? When I used to actually work for a .com e-commerce site, this is exactly what we did. We gathered their information, stored it in a database, and then sometime in the future, when we actually fulfilled the order, then we charged the card. In fact, I think we turned off almost all validation whatsoever to just get all their information in, and if anything went wrong, then we call them. So we put that to the business. Like, I'm going to have to call people? Like, okay. So this does put a burden on the business. They have to call people, but it does mean I get the most money possible from my customers. All right. What about SendGrid? Do I have to send the money now, or do I send it later? What is the actual time I should send them an email to say, your order is accepted? Is it when I insert a row into the database? Not really, because their credit card could not go through. I'm not going to send them an email saying, thank you for your order, and their credit card got declined. So we asked the business, like, what is the actual trigger for us to send this email? And eventually, after about 10 minutes conversation, they said, when we charge the customer. When we charge the customer, that means the order is good, send the email. So we looked. I Googled Stripe triggers, but not like database triggers, because that would be silly, right? Right. So not a database. Like we want to trigger something when something succeeds in Stripe, and it turns out they support this via webhooks, which are like web version of database triggers. But that's essentially what it is. Like something happens, call this code or call this API when that thing happens. And so with Stripe, I can set up an API endpoint that they could ping me when a Stripe transaction succeeds. We looked at this, but the problem we ran into is we didn't know what their policy was for retrying these things. Like, what happens if my API is down? You called me for the webhook. Like, that just introduced more uncertainty. So we're like, well, we could do this, but I don't know. Maybe the documentation down here is good, but it was too much uncertainty for us in this case. So finally, we looked at RabbitMQ and said, what does it mean to not send the message now? This is kind of a weird one, because I kind of assume this is up at all times, but how do I not send a message? How do I flag something to need to be sent? I could flag the individual order, but what people actually wind up doing, and you've probably done this as well. Does anyone have a database table with an isProcessed flag on it? Right, so you're doing exactly that. Something is looping over, looking for things that need to be processed and sending them out the door. This is actually known as an outbox pattern, where I am not sending the message now, I'm putting it somewhere else, and then sometime in the future, something's going to take it out of my outbox and actually send it down the road. So this outbox actually gets stored inside of SQL Server. So instead of me calling RabbitMQ directly, I just store the message temporarily inside of SQL Server as part of this database transaction. I don't call Rabbit at all anymore. Instead, something is just looping over forever my messages. When it gets the messages out, then it will go ahead and send those messages out the door. Okay, so we did all this and said, you know what, this is still pretty ugly code, and we're now introducing more potential places of failure that we can't control, like with Stripe webhooks. So we looked at this and said, we're still not there. There's still way too much going on in that one single button click. We're trying to just say, can we do this later? Like, do we need to do any of it in the context of that button click? Can we do all of that stuff sometime else and make the button click as dumb as absolutely possible? This is actually what we did at the e-commerce place that Glenn and I worked at. The button click was literally insert row in database, and that was it. Like, insert row, done. And if that fails, then like we're doing so many other things wrong if we can't insert a row into a database. So could we get to that point where we're doing as little as possible, reducing the amount of possible failures to just the bare bones, like if that doesn't work, we should just go home and call it a day? Can we put some of these things just completely off the table and not do them in the context of that single button click? Again, I have to talk to the business. By the way, if you're a developer that doesn't like talking to the business, you're going to get called later when your stuff breaks. So it's better to talk to them now and try to get things worked out than called later when everything's broken. So we looked at all the different things and said, okay, do we have to do this as part of the button click? Does it make sense to do it now, or can we actually do this later? Is it actually better for us to do this later? So we looked at all three of the different things we called and said, do we need to do this now, or can we do it later? Stripe, that depends. Do we need to take the money now in the button click, or can we take the money in the future? So we asked them, do we need to do it now or later? In this case, they could tell us, well, I want to minimize the number of times I show an error screen to a user. Like showing an error screen on checkout is the worst possible thing. So process the payments offline, and then that way if something goes wrong, the only thing the user sees is like, thank you for your order. And if something goes wrong, it still says thank you for your order. It's just all back behind the scenes. The same thing with SendGrid and RabbitMQ. Like, if I'm on a website checking out, do I also have my email open right then to be like, button, ooh, did I get the email? Like, I hope you don't do that. So this one, there's already an assumption that something's going to be sent in the future, not right now, so we can go ahead and send that offline. Same thing with RabbitMQ. We don't have to do it right now. We can do it sometime in the future. So what we're going to do here is replace our process that just did call A, B, C, D, and then now take that and process it all offline through some kind of back-end workflow. Now something has to kick this workflow off, and so we can use something like Hangfire to do so. So that outbox thing we saw earlier, it can just loop through any kind of unsent messages and then send those messages out the door and then delete them out of the outbox stored in our database and just run this, I think that's once a minute, just like, are there any unprocessed orders needing to be processed? And then send the message out the door and then go on to the next one. So now it looks something like this, where I have a very small, simple API call that literally just inserts a row into the database, and then something behind the scenes is looking for unprocessed orders to kick off something that then does these other things. Now, we could just take those 3 lines of code that were Stripe, SendGrid, RabbitMQ, and put them in this, whatever that is, but we already saw that those things have problems with each other. We want to break those things up. I don't want SendGrid being down to affect me taking money from people. So we want something to manage this back-end process behind the scenes. This is where we start having to look at more and more books about what's possible, because this starts to get into messaging patterns and asynchronous workflows. Things get complicated, as we'll soon see. So the first option we looked at is for managing these 3 steps together was a pattern known as routing slip. The idea behind a routing slip is a message passes from one point to the next, and each step just performs its steps and forwards it on to the next thing. So it looks something like this, where I notify the Stripe service through a message. It does its work and forwards it on to the next step to say, OK, now send the email, and then forwards it on to the next step to send to RabbitMQ. There's a problem with this, though. It's very simplistic. If anything goes wrong with any of these steps, I can't really easily recover from it. So it works really well for a very straightforward process. So manufacturing facilities do exactly. This is like an assembly line, going from one step to the next. So if everything's just an assembly line, then everything's good. But if anything goes wrong, then stuff really starts to break. So this probably won't work for us. A more complicated one is known as the saga pattern. The best example I've seen of the saga pattern is something like a reservation for a trip. So when you want to book a vacation or holiday, you want to book a hotel, you want to book your flights, and you want to book transportation. Yes. And if one of those doesn't work out, no vacation. But you can't do a conference call, get everyone on the phone and say, all right, everyone ready to go? I'm going to book a trip. And you wait for like American Airlines to call. Like, no, that doesn't work. So instead we have this concept of a series of transactions that commit, and if something goes wrong, they roll back. So in this case, we need a car, hotel, and flights. So we first book the rental car. We then book the hotel. We then try to book the flight. But if something goes wrong, then we undo each of these steps. This is known as the saga pattern. This works really well if we can undo steps. But we've already established 2 of our things we can't undo, so this is out. So it's at this point that you just make up whatever workflow you want. Like, the simple things didn't work. Now you're on your own. Do whatever you want. And in fact, the book that details these patterns, the saga pattern, the routing slip pattern, there's a section where he talks about a process manager pattern, which is the idea that I have these messages coming in, I have to decide what to do next, and then I got to do more stuff. And it's extremely vague with no detail, and he ends that section in a very long book that says, this deserves a book all on its own for just this topic, and someone should write that book. That was 12 years ago, and no one's written that book. But there's good news. The guy that wrote this book, he actually started the new book to detail these patterns. And it's coming out like next month. So the same person that had that two-phase commit coffee shop, Gregor Hope, wrote the Enterprise Integration Patterns book, which is what basically all this talk came from, is talking about this in much more detail, the process manager pattern, which I just had to make up myself when I was doing it, but he's going to write it all down. That's great. So this process manager pattern, the idea here is that I have something that's coordinating a set of activities through messaging. So everything is some kind of asynchronous message to other things to do work. And then it's just kind of the thing in the middle saying, okay, that's done, okay, ooh, that failed, go do this other thing instead. They're like a good kind of boss that's not like telling you what to do. They're just kind of directing like, ooh, sorry, he's my boss. They're just in there, they're just kind of listening to what's going on and providing feedback and direction as they learn things that have happened. So the two basic kind of ways you can build these things, there's two basic ways. The first is what's known as choreography. Choreography is where you explicitly tell each step what to do and when. Oh no, I got it backwards. Crap. Did I? I don't remember that. Like the terms don't even make sense. But it's the idea that I am explicitly telling each step to do its work, and I am the one in control. The other one, which I believe is orchestration. I think I got these backwards. Did I get these backwards? Yes? What am I asking you, Eduardo? You know. Okay, orchestration is the, I definitely got these backwards. Choreography is where I'm telling things to do stuff. I should fix this. And orchestration, I don't remember. One's command-based and one's event-based. That's probably better. I call these things different stuff when I blogged about them years ago. And so the idea behind that is you don't care about the order in which things happened. You just say, do some work things, and when they're done and get back to you, you make decisions about what to do next. So it's a difference between kind of like explicitly controlling the steps versus just saying, hey, everyone do your work and let me know when you're done. And when you're done, then I'll decide what to do next. And in order for us to decide what to do, we look at what steps need to happen before others. So in this case, we know that we actually need to call Stripe first before we do SendGrid, because they're not supposed to get this email before they get that. So what we actually want to have happen is we call Stripe, get a success or failure, and then we go ahead and say, okay, now other stuff, do your work because I've successfully got your money. So I got to fix these terms. I think they're wrong. It looks something like this. Call comes in from the outside, makes a call to our API, just inserts a row in the database. That's it, nothing more. At this point, the user gets the, okay, order successful, thank you for your order, and maybe a link to get back to the status, which is, again, stored in that database. Then we have some sort of background task that is pulling unprocessed orders out and then sending a message down to this thing over here that's actually going to process the order. This process manager gets the details out of the database, and then next makes a call over to Stripe. Now, it does this again via message, so that if something goes wrong with Stripe, it doesn't take this entire thing down. We're separating out and saying, I'm going to send this another message to do its work, and then at some point in the future, it's going to tell me the result. Did the payment succeed or fail? And finally, I need to notify this downstream systems, and the cool thing is that I don't care about who does what or exactly the order they happen in. So in this case, I can use that same RabbitMQ message that we're notifying other downstream systems. I can do the same thing with SendGrid. So we send one event out to all these downstream systems, whatever these are, like fulfillment, shipping, whatever, and notification to the end user for email. And now I have a system that can completely be online without any of these back-end services being up or not. So what did we actually do in our company when we saw this happen? It was actually about 40 minutes ago. Sorry. The thing we actually did, so we wound up going with the undo in our situation. We did the call Stripe. If Stripe fails or something fails later on, then we'll issue a refund. That was what the business was comfortable with. Most e-commerce systems that I'm aware of use something like this instead, where they make it as dumb as possible to take your information, just the most stupid possible code you could possibly make. And in fact, like a lot of times we don't even use like entity framework. It's just like insert the row directly into the thing and then have as little things that could fail as possible so that we guarantee at least get your information, and then have some kind of back-end processing system that actually takes care of the order in which things need to happen, calling Stripe and then notifying people via email. But this is all a 100% offline process. Now, I do have a code example, but I think I'd rather not do that because it's going to be a lot to explain. So what you can do is go to my GitHub, and then in this folder in the presentations repository, there's a complete working example of this picture here. And you can run this API without anything else running, and it can still accept orders. And then you can bring up backend services, and it can actually process orders without affecting anything on the front end. So is everyone okay with that? Because there's a fridge full of beer behind me. And I'm the only one keeping myself from it. So that was Fixing Distributed Systems Fail. If you want more information about this, or you want to see the actual example behind the scenes, you go to my GitHub. There's a presentations repository there, and that has the full working code example there. I'll be posting some links in that repository, too, for the books and other articles that I mentioned here that I had to take like a week to absorb before we had our next conversation with my worried developer. Oh, by the way, my developer was no longer worried. By the time we got to the end of it, he just saw a lot of code we had to fix. So thank you very much. I hope you enjoyed the presentation.